GT.
Going for way backwards.
N term is there in the GT folder.
Perfect. I'll open that
Hmm.
instead of this. Yes, for this paper, we are good to go. Others, I depended on. So this is where we are at. The question being, this is the networking. This is from the networking week, which is week 9. The market for a single network good is given as U of theta is theta times A plus Vn. It is plausible that a user who has a higher value also assigns more importance to the size of its network. Very true. For instance, to think of a real life example, you are more likely to select a product if you know multiple people use it, because the fact that people use it means that by and large it is reputable, it is reliable, and chances of after sales support are also higher. The best example of this being vehicles, even electronic gadgets, laptops, or I'm not sure if people still use desktops these days, but so we have A as the standard benefit, B measures the network effect, and NE is the expected number of users joining the uh, network. Theta is uniformly distributed on the unit interval. The question we have is theta corresponding to an indifferent consumer for a given price P and a given expected network of size N. This is a theoretical concept which is directly picked up from the lecture. So this works out to be, there is no maths involved here. This is just application of the basic formulas that are given there. Just you just have to remember the formulas. There are a total of I think 5 or 6 formulas in week 9, and unfortunately each of them is important, which means that all of them have to be prepared. So this question is mostly theoretical, and that means week 9, mostly the expectation is that we'll get theoretical questions. The maximum value of P to have buyers will be A plus VNE. This comes from the graph which is drawn, and that resembles a downward curve, something like this. And this point is A plus VNE, and at this point it is minimum. That is the extra concept of reserve. Then mass of buyers as a function of theta hat, it is going to be 1 minus theta hat. Absolutely theoretical, no calculations here. This is a question from the graded assignment. Willingness to pay for the nth unit of the good when NE units are expected to be sold is A plus VNE into 1 minus N. This one can be derived. It does not have a solution per se, but it can definitely be derived. And the way to derive it is, let me think. Actually, no, this is a straightforward formula. The only difference is at some point they will ask fulfilled expectation demand curve. And at fulfilled expectation, you know that N becomes NE. So this component effectively just converts into Bn. And that is the expected, the fulfilled expectation demand curve. Unfortunately, my stylus has started.
Right. So you said the maximum price they would pay would be A plus Vn to the power E, right?
Correct.
So we are looking at a uniform distribution between 0 to 1
0
for
to 1.
number of products being sold.
Yep.
So you are just doing 1 minus n. That means so much potential is still left to be sold.
Correct.
Okay, we're just getting a fraction there. Okay.
Correct.
Hmm.
P of NE is and comma N is a decreasing function for NE and an increasing function for N. Sorry, other way around. Decreasing function for n, increasing function for ne. I don't think there is a derivation for this either. But I do remember this formula. So the formula goes essentially something like, let me see if I can write this here. P of ne and n is essentially a plus vn into 1 minus n. This is the formula. And from this, we get a minus an plus vne minus nvn. Then the next step is differentiating this with respect to both NA and N. With respect to NE, we get an increasing function, and with respect to N, we get a decreasing function because the derivative for NE is positive and the derivative for NE is negative. Minus of A plus VNE and V of 1 minus N. So the important point from this is just to remember this base formula, A plus VNE into 1 minus N. And then this helps in understanding the demand that is already been satisfied and the pending and the demand that is still available. Decreasing function of N and increasing function of NE. Here it is. Expected fulfilled expectation demand curve. N is equal to NE. And you get the same expression. A plus VNE gets substituted with A plus VN. This comes again from the previous formula, P of NE comma N. Right. Next up, we have calculate the Shapley value as the average of players' marginal contributions for this given game. We have a 3-player game, out of which we have the available. Let's see if this works. Yes. Okay, we are back to this. Sorry. Yes. So this is a pretty straightforward question, guaranteed to come into the paper. Shapley values. This is week 11, I believe. The way to solve this is there are two ways. The first way is you make the table, which is what has been recommended, and the table will tell you the contribution for the contribution for 1, 2, and 3 in that particular order. Another way to do it, which is much easier, is to remember the formula. The formula tells you that Shapley value for player I is going to be 1/3 of B of I minus B of phi plus 1/6 of B of I comma j minus B of j plus 1/3 of total minus B of j comma k. And this makes life much easier. So now all we have to do is plug in the values to get the in this formula to get the Shapley value for each player. So if we try to solve for S1, we get 1/3 of 6 minus 0 is 6 plus 1/6 of I comma j is 1 comma 2, 12. 12 minus 12 is 0. Plus we have 1 comma 3, which is 12. B of 3 is 18. 12 minus 18 is minus 6. 0 minus 6 plus 1/3. Total is 48. 2 comma 3 contributes 24. So that means 48 minus 24, which is 24. This is 2 minus 1 plus 8. So we know that Shapley value for player 1 is 9. Similarly, if we calculate for player 2, Shapley value for player 2 is going to be 1/3 of 12 minus 0, which is 12, plus 1/6 of 1 comma 2 is 12, of which V of 1 is 6, so 12 minus 6 is 6. V of 2 comma 3 is 24, out of which 3 contributes 18, so this becomes another 6. 24 minus 18 plus 1/3 of the total, which is 48, minus 1 comma 3, which is 12. 48 minus 12 is 36. And we get the final answer as 4 plus 2 plus 12. And similarly, we'll solve for S3. Does anyone want to try for S3? Any takers for calculating a Shapley value of layer 3?
Easy way would be total minus the sum of 1 and 2.
Exactly.
9 plus 18 is 27. Subtracted from 48, you will get the total. They all have to add up to the total, right? Anyway.
Yep.
Yeah, I did the table method. The answers match.
Perfect. Paper might not match given that GT answers are often correct, but yes.
Yeah.
3 firms that are considering entering a new market. The payoff for each firm that enters is 150 by N. This is a question that has been asked in, I think, all papers.
Yeah.
The payoff for each firm that enters is 150 by N, where N is the number of firms. The cost of entering is 62. Now, if you look at it, there are a total of 3 cases here because each firm is synonymous with the other. Case 1, nobody enters, all of them avoid. Case 2, there is 1 entry and 2 avoid. Case 3, 2 enter, 1 avoids. And actually case 4, all enter. Now the way to solve this is to calculate the payoff for each firm in each of these cases. So when all of them avoid, the payoff is going to be 0, 0, 0. When only one firm enters, the payoff is going to be 150 divided by 1 minus 62. Why 62? Because that is the cost of entering. So 150 minus 62, that gives me 88. When 2 firms enter, it is going to be 75 minus 62. That is 13. So these 2 firms get 13, 13, and the last one is still avoiding, so it gets 0. What if all 3 enter? 50 minus 62 minus 12. So this is the equation we have with us. Now, apart from case number 1 and case number 4, the two remaining cases can have 3 different variations each. For instance, for the first one, it can be EAA, it can be AEA, or it can be AAE. Similarly, for EEA, it can be EEA, EAE, or AEE. All of them are equivalent. These three are symmetrical, these three are symmetrical. So if we are asked how many pure strategy equilibria are in this game, what we are being asked is which of these payoffs is the one at which no firm will want to change. So we have 4 cases. Let us evaluate all 4. If we are at AAA, then at least one firm would like to switch, because when there is only one firm in the market, the payoff is 88. Now we are at the second strategy. Here also we see that yet another firm would like to enter. Why? Because the payoff of 13 is better than this 0. So now we come to EEA as a strategy. And from EEA, we realize that nobody would want to shift. The last firm would not want to enter, because then the payoff becomes minus 12 and it is already at a better payoff of 0. And none of the other firms would want to exit, because if one of them exits, its payoff becomes 0 and the current payoff of 13 is more than 0. So EEA is the equilibrium strategy. And because there are 3 such variations, we get 3 strategy equilibria. Any questions in this one? Okay, moving on.
Nicely explained.
Moving on. In one of these pure Nash equilibriums, all 3 players enter the market. False, obviously, because there is no way in which all 3 will enter the market, because as we know, when all 3 enter, the payoff is minus 12, minus 12, minus 12, not decidable for any of them. So 13, 13, 0 is the equilibrium point, and that is the one they will consider as a winning strategy. Next question. There is a symmetric mixed strategy equilibrium where all 3 players enter with the same probability. Find the value of P. Now, if all 3 players are entering, then I have to find the equivalent payoff. And how do I do that? In the first scenario, the payoff is obviously 0 for all of them. So no matter whatever the probability of entering, the payoff is 0. So the net result of that strategy is going to be 0. Let's move on to case number 2. When one firm enters, its payoff is 88, but it only gets this when the other 2 stay away. And the probability of the other 2 firms staying away is 1 minus P whole square. Why whole square? Because if P is the probability of entering, then 1 minus P is the probability of not entering. And I get 88 only when both firm 2 and firm 3 choose to avoid the market. That is going to happen with the probability of 1 minus P into 1 minus P, and hence 1 minus P squared. Any questions in this logic? Fair enough. Moving on. Next up, we add the payoff from the second game, which is 13. Now, with what probability do I get 13? 2 firms entered, so P plus P, and 1 firm still stays away, so 1 minus P. And finally, a payoff of minus 12 when both the other firms enter the market. This net game, the result should be 0. Now we get a quadratic, which is 88 into 1 minus P squared plus 13 into 22 into 1 minus P plus p square into minus 12 is equal to 0.
Then, just 1 second. In the formula that you wrote, minus 12 should be p cube or p square?
P square, right? Because this is what we're already considering in here is
But
p.
there are three. There are three.
But 1 has already entered, right?
Okay.
The minus 12, how will the minus 12 come? When 1 enters, right?
So the one
Otherwise,
previous to that, this 2p plus 1 minus p. 2 entering
and
plus
1 staying
1
away, not plus, into.
into. So here
Yep.
also shouldn't it be all three? So everywhere. Okay, fine. Just continue. Let's see.
Yep. Okay. So we have this quadratic equation which needs to be solved. Eighty-eight minus 26 minus 12. So we get this final equation, which is 25p squared minus 75p plus 44 is 0. Right. This here somewhere. Okay. 25p squared minus 75p plus 44 is equal to 0. Now I know p is the roots of a quadratic equation are given by minus b plus minus the root of p square minus 4ac divided by 2a. Hundred into 44. $75 square is 5625 if I'm not wrong. 5625 minus 4400 is 1225. Oh. Oops, made a mistake somewhere. Okay, in maths, undoubtedly, but yes. That is
What
the mistake.
what is it?
This 2a is over everything, not just this. This is the actual mistake. Oh, I'll have to do it again. 25p squared minus 75p plus 44 is 0. P is minus b plus minus the root of 75 squared minus 4,500, 5625 minus 4400, which is 1225, divided by 50, which is 75 square root of 1225.
75 plus minus 35. Okay.
75 plus minus 35 divided by 50. 75 plus minus 35 divided by 50. Now, obviously, it is a probability it cannot be more than 1. So the plus option is disregarded, and we are left with only the minus option, which gives us 40 by 50, which is 0.8. Or the other option would have been 100 and what 110 by 50, which is 2.2.
Hmm.
Since it is a probability, the answer is going to be 0.8.
Oh, isn't okay.
See again, sir.
No, I was thinking, isn't this minus b square, right?
Hmm?
No, the formula, quadratic formula.
Minus b plus minus under root of b squared minus 4ac divided
Isn't
by 2.
is it okay? I thought it was minus b square.
No, no, no.
I'm
Minus
forgetting.
b plus minus under root b squared minus 4ac.
I can, yeah, we'll check it. We'll confirm that. Okay.
Yep.
Answer is 4 by 5, right?
Yep.
We could have, isn't it easier to use factors and solve it?
Factors.
I mean, it's possible, right? Like the way we should do it in math class, math course. Okay, let's move on. Yeah, let's move on.
100% doable, but
Hmm.
this was an easier way for me. Market A has two buyers and one seller. One has a watch whose worth for him is 200. Two and three potential buyers who do not own a watch. The worth of the watch is 280 for player one, 300 for the other player. Each buyer is interested in paying the lowest price of the watch and unwilling to pay more than the watch's worth to him. Describe the gaming coalition form and answer the given sub questions.
Okay.
Who wants to solve this one? V of 1.
That's the value, right?
Yep. That's the value, correct.
So V1 is the seller.
Hmm.
So 200, right?
Correct.
Hmm.
Next question is V of 2.
V2. What are the values? Buyer who do not own a worth is 280. Each buyer is paying the lowest way. I need to more than the watch's worth is 200. Why would so they will not pay more than 200?
But what is the current value that player 2 brings to the table?
280.
No, sir. The value of player 2 is 0. Right? Because this is a coalition form game. That means player 1
They
is
have
the
to,
only
okay, they have to buy together.
Yes, player 1 is the
Individual
only
will be
one
zero.
bringing anything to the table. V2 and
Right.
V3 is 0.
Zero. Individual will be zero.
Correct.
Hmm.
V of 5.
If not sold, right?
Hmm.
If nobody takes it,
If nobody takes it, it remains with the seller.
seller. So the seller will get 200, right? The value or zero.
Seller already has it, right?
So okay. So if no sale means zero. Okay.
Correct. V of 2 comma 3.
All right. Now they buy it.
Nope, they haven't. One is the seller, remember.
One is the seller.
Hmm.
Okay. Right. Right. So here
Eh,
also will be zero then.
Correct. Any correlation without 1 will have the value 0 because 1 is the only one who has an item of worth.
Okay.
Now V of 1 comma 2.
Mm. So it's worth is 200. He sells it for 280.
Hmm. Okay.
Now how do they share this? So is it that
Player
that
1.
is the cost?
Hmm.
Will it be 80 or what? Uh, how is it divided? So
It's not right.
280.
Yep.
Okay. So it's 280, right? Okay.
So originally I had 200 for player 1 and I had V2 as 0, right?
Mm.
Now I know that player 2 values the watch at 280. So he's going to pay that 280, right?
Yeah.
And then V of 1, after this happens, V of 1 is now 0 and V of 2 becomes 280. So what does V of 1 comma 2 then become? If we go by the rule
P
of
of 2 is 0, right? There's no
no,
value.
2 owns the watch now, right? 2 has purchased the
Okay.
watch.
Now, okay. After the sale.
Huh.
Mm. So V1 will get the price, right? Whatever V2 has paid.
He gets the price, sir, but the value of the item, the coalition's value is determined by the worth of the watch in this case, not the money.
Mm.
The money is never the worth of the coalition. It is always the
Payoff,
amount.
no? It's not about the watch. It's the payoff.
No,
It's
it's
not
about the
what.
watch.
Okay. I
Otherwise,
was thinking that the V1's payoff will be 200 because they valued it at 200. V2 will get 280 minus 200, which is 80. So total will be the coalition value will be 280.
actually, that is not a wrong way of
Okay, it's
putting
okay.
it.
Continue. Let's see. Let's see. We'll figure
That
it out.
that that makes
So
sense.
1 3 will be 300 because that's the price they're paying, right?
Correct.
Okay.
1, 2, 3.
0. I
Uh,
don't. They can't have two buyers, right?
why not? I'll sell it to the buyer to the higher buyer, right?
To the higher buyer. So 300.
300. Yep.
Okay. So
Now
here V2 is null. All right.
correct. V2 is the null player in this game when you have player 3. Now we have a base theorem question. 40% of all your emails are spam. So P of spam is 0.4. P of not spam is 0.6. 1% of all spam messages contain the phrase check this out. So that means P of spam given phrase is there. Sorry, other way around. Probability of the phrase being present given that the message is spam. Yep,
So T phrase bar spam, right?
correct.
Mm,
Phrase given spam is 0.01%.
right. And P
Phrase
not
given not spam is
0.04, 0.4%, right? Mm. So total probability of phrase occurring, total probability, right?
Yep,
So that will be P of PS
0.4 into 0.01
plus
plus
P1
0.6 into 0.004.
0.4 into 0.01 plus
0064. Any questions on this one? Okay.
0.0024 totally 0.006.
64. Yep, correct.
Got it. Oh, okay. Cool.
Yep. Probability of the message is spam if the subject contains the phrase. Check this out. So now we have to find probability of spam
Yes,
given
given.
phrase.
Mm,
This is going to be probability of phrase given spam into probability of spam
what?
divided by probability of the phrase being present, which we know is 0.0064.
Right. So
I actually forgot what was this value. Probability of the phrase being present, given that it is spam, multiplied.
uh, 0.01
No, 0.04 or 0.6. What was it?
of spam is 0.4.
This is the equation we get, right? 0.04 divided by 0064.
Yep. Okay. 0.004 divided by 0.0064. 0.625.
Yep.
0.625. Got it.
Cable TV. Let's go.
Yeah. So this one he has explained, right? How to do it easy.
Yep. So the first thing to do is, okay, there is a twist here.
Hmm.
The twist being that layer 1 is not connected to the junction. Layer 1 is connected to the station directly, or rather user 1, customer 1, whatever it
Yes,
is.
but everybody will share the cost of this one, no? Because it's common.
Yep. So the cost for player 1 is essentially going to be
6.
18 divided by 3, which is 6.
Okay.
Cost for player 1 is 6. Cost for player 2 is going to be 6
Plus
plus
half of 24 plus 10.
10 or acha 10, yes.
Oh, sorry.
You are right, you are right. 10,
Oh, yeah.
correct. I was checking this one for 3.
Mm,
So 6 plus 12 is 18, 18 plus 10 is 28.
mm.
Cost for player 3 is going to be 6 plus 12, that is 18, 18 plus 12, 30.
They all have to add up to the same value. So 34, 64. Here we have 22, 40, 64. Yeah, all costs are made. Let's check.
6, 28, and 30. All
Good
done.
job.
Good to
Mm.
go.
This is thanks to that guy,
Gopal.
Gopal. Yeah. One answer he explained.
5 bidders with private, you're not wrong. 5 bidders with, sorry, let's get back on track. 5 bidders with private valuations uniformly distributed between 0 and 1
Mm.
participate in a sealed bid first price auction. Everyone is playing the symmetric equilibrium bidding strategy. What is the optimal bid for a bidder with valuation 0.75?
Okay, so n is equal to 5, right? So n minus 1 over n into the valuation for first price, 0.75. So 2/3 of 7, right? No, is it n minus 1 over n
Ah,
or n plus 1?
N minus 1, you are right.
Just n minus 1 over n.
Yep,
Yeah. For expected revenue, we need to do plus 1.
correct.
Okay. So this is 4/5 of 0.75. 0.6. Yeah, 0.6. Yeah.
Expected revenue of the seller is going to be,
N
uh,
minus 1 over n plus 1.
yep, so 4 by
Two-thirds.
6, 2 by 3, which is 0.5.
2 by 3, 0.66.
No, no, 2 by 3.
Hmm.
Okay, right.
Nothing else. There's no
Yes,
valuation here.
yes, 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 yes,
Yeah.
yes. 0.66. Okay,
Yeah.
they just left the fraction fair. And fun.
That's
One
it.
touch.
Didn't ask anything else in
Nope,
this. Wow.
3 marks, that's all.
Okay. So he
Two
asked
this.
something else this time.
Yep. Most likely he might ask theoretical questions
Okay.
around the core.
Hmm.
He's going to ask bankruptcy on the basis of the contested garment principle.
Hmm.
And one more aspect from week 12, which I think is what is that one? The clickbait thing. The sorry, not clickbait.
CTR. No, that is a
Sponsored search market.
CTR. Yeah. That's easy to do. Right.
Ah,
The advertising one, right? The advertiser
yep,
click through.
correct. Those three he's going to ask. I
Yeah, so
mean, one.
here I think we should do both. We should study this as well as the SPA, second price valuation, second price auction. They
First
have
price,
different.
second price have the same value. Na? So n minus 1 upon n plus 1 is the expected payoff.
Yeah.
And the
Uh,
optimal bid is always your true
but
bid.
if we ask the realized revenue, then you have to actually find the value,
Then you'll have to know what is the bid made by the second person.
right, by the second person. Very good.
Correct.
Okay. Next.
Two division managers can invest time and effort in creating a better working relationship. Each invests EI is greater than or equal to 0, and if both invest more, then both are better off. But
Hmm.
it is costly for uh, each manager to invest. In particular, the payoff function for the player I from effort levels is A plus EJ into EI minus EI square. This is the payoff. So now, if I have to find the best response, I will differentiate
With
this
respect to I, right? AI.
with
Okay.
respect to EI, correct,
So I'll get
which will give me A.
A plus EJ minus 2 AI. Right. Hmm.
Best response correspondence for player I is A plus EJ divided by 2. We just solved that. Keep going. Nash equilibrium of this game. So basically, what we need is LHS equal to RHS, which basically means I need EI is equivalent to
EI equal to EJ. It should be A, right? Not E.
huh?
Okay, all right. Anyway, so EI over E plus EJ is equal to A, right? 1 equal to A. I just solve this, no? Simple.
सही तो है. What?
Hmm. EI is equal to E2 is equal to A. हाँ ठीक है
हाँ,
तो
yeah,
यहाँ पे A का वैल्यू नहीं है ना, so it's just A.
correct, correct. Oh, here it is. The ads clickbait. Sorry, ads. Advertising one. Suppose the search engine has two ad slots which it can sell.
Okay.
Slot
Two.
A has a click-through rate of 10, so that means click-through rate and slot click-through rate 10 for slot A, and slot B has a click-through rate of 5. 3 advertisers. Advertiser X values clicks at rupee at 3 per click, Y values it at 2 per click, and Z values it at 1 per click. So that
Yeah.
means what is the valuation for X, Y, and Z if they are given any of these?
Right. So the thing is, the company selling the ads will sell it to the highest player first. So the
Correct.
highest click through will go to the highest paying advertiser.
Yep. So what this essentially means is that since X values them at 3, X is going to value this one at 30
Right.
and this one at 15.
Yeah,
Why?
you don't need to calculate that. They'll only go for the first one.
Yep.
Then second one would be 2 and 5. So second slot will go to the second highest player, and there's no more slot, so the third advertiser will get nothing.
Third does not get anything. Absolutely correct.
So 30 plus 10, 40 total valuation.
Socially optimal valuation is 40. Correct. Socially optimal allocation is 3 into 10 plus 2 into 5, which is 40.
Hmm. We are the only ones talking. You realize that?
Yep.
Okay.
Now we have BCG. I have forgotten the full form of BCG. I just remember it's Vickery something.
Yeah, so I have that. You have to calculate the
Ah,
slot
I know, I know. You
with
have to.
X and without X.
Correct. The harm that is being done to Y and Z because of X.
Yeah.
So now what this basically means if for slot A,
Hmm.
the question being posed to us is what if player X was or what if advertiser X was never there? What if we
Yes.
just forget about X for a minute? What is the situation like then? What is the payoff? So if X was not there,
Yes.
then
So if X
Y,
was
which is
not there, right. So
Y,
Y and Z will get promoted.
correct. Y, which is currently getting 10, would have been getting 20, and Z, which is currently getting nothing, would have been getting 5,
Yeah.
which is 15.
Yes.
Any questions on this one?
Nope. Same thing we have to do for, I think, B.
Yep. B is straightforward. If Y wasn't there, X anyways is not going to go because X is happy with A and Z gets 5.
Yeah. So.
Pretty much straightforward.
Mhm.
Here we are, bankruptcy. A man dies leaving an estate worth 500 units. The deceased has 2 creditors. One's claim is 400 and the other's claim is 300. The division of the estate between them is carried out according to the contested government principle. Now, what we know, total is 500. One wants 400, the other wants 300. Now, if we look at creditor 1, creditor 1 says that creditor 2 can have the other 100 uncontested, leaves 100 for creditor 2 uncontested. And if we look at creditor 2 leaves 200 uncontested for creditor 1. The way you get this is how much is the estate value? Estate value is 500 minus the claim for a creditor I. is the amount that they are leaving for creditor J. Leave for everyone else.
Right.
So now what we know is that 200 for creditor 1 and 100 for creditor 2 is uncontested.
Mm-hmm.
So that means out of 500, 300 is uncontested and 200 is contested. That
So,
too, that 200 will be split equally between all creditors. In this case, two creditors, each one gets 100. So this becomes 300, comma 200.
no, I didn't understand. Sorry, I missed a step.
Fair enough.
So we got 500 minus claim I. That part is clear.
Hmm.
So creditor one will leave 100, right? That part is
Ah,
clear. And two will
correct.
leave 200.
Correct. Now, how much have that means that creditor one has claim has access to 200 units already because that has been left by creditor two for him.
Right.
Likewise, creditor two has access to 100 because creditor one has left that for him.
Right.
So that means creditor
They'll
one,
start with that. Okay. So they'll
yes, they
start with.
start with that and
Okay.
you take out that from the estate's net worth. So this was 500 and 300 of it has already been peacefully uncontested
Okay. So
divided
what will
uncontested.
remain? Okay. So uncontested you start with and then you add the remaining equally.
Correct.
Got it. Right.
Contested ones you divide equally among all creditors and let that be. So it is 300 for creditor 1 and 200 for creditor 2.
Okay.
All good. Five numbers are drawn independently from the uniform distribution on the interval 0, 1 and then sorted smallest to largest. Expected value of the number in second position. We know this is k upon n plus 1, which
Right.
is 2 by 6, which is 1 by 3.
K is always the smallest, right?
No, k is
Large.
the position.
Yeah. So that is smallest. To start with, it's smallest. Second position means.
Because they've mentioned, right, it is sorted from smallest to largest. They
Right.
might invert it, they might give you largest to smallest.
Right. Then you have to take the inverse of this. You have to just change the list value.
Absolutely correct.
Okay.
This was more of a theoretical question. In a
Mhm.
weighted majority game, 7, 5, 4, 3, 1. So we know that quota is 7.
So this is majority voting. We need to have seven to be able to pass any rule or pass a vote.
Correct.
Right. So we have to see which coalition of players alone or in coalition can pass and which ones are useless, null players.
Correct. So
Okay.
nobody can pass it on their own. So there is no dictator in this game.
Right.
5 and 4 together can pass. 5 and 3 together can pass. 5 and 1 together cannot pass.
Cannot pass.
4 and 5 can pass. 4 and 3 can pass. 4 and 1 cannot pass.
Mm-hmm.
3 and 1 cannot pass. That means 1 is useless. 1, when paired with anyone alone, cannot pass any coalition, cannot pass the vote.
Mm-hmm.
All others combined can easily pass. So therefore, 1 is the null player. Sorry, the player with contribution 1 is the null player, in this case it is player 4.
Oh, okay. Right. Right.
Yep. The player with 1 contribution is the null player.
Mm.
Crowd can be wrong even if everyone in the crowd is rational and everyone takes the same action. Correct.
True. Look around.
Yes. Aggregate behavior of many people with limited information can sometimes produce very accurate results.
True.
Also true. Case being when you draw a red ball from a red majority urn.
If you ask, fill up a jar with pebbles or marbles, and you ask people to guess, you take the average value. It will be close. That will be the correct answer. That
Yep.
was the experiment that was done actually in history.
Yep. A stable matching system is a system under which everyone is satisfied. No, the matchmaker is happiest because their decision is honored. A matching system is stable when an unmatched pair may find it beneficial to deviate from the matching and form their own match. False.
Not allowed.
A stable matching is necessarily a system under which everyone is satisfied. False. And
No.
okay, so this is basically A, B, both none. Answer
Mm.
is none. This is theoretical. We don't have to rack our brains for this one. And that's the end.
Not bad, yeah.
Yep.
Okay, end term is definitely easier than the first two quizzes.
Yep. So that is a plus point for us.
But the group is very quiet today. I mean, nobody.
Everyone is tired.
Okay. Everybody else is doing something else also. Okay. Thank you. Thanks. By the way, any more PYQs?
This was the one which we were left with. We can take a look at the others, see if there is anything that is extra.
Different. Yeah. So he's going to make a mix and match.
Yep.
And so this is the first question.
Yep.
Okay. So sum means that the value given on top
Is
or
the
the
total.
left. Yeah. Sum of these two. Right. So it's a very easy. It's like a children's puzzle.
Yep.
Okay.
This is easy. This gives us 2, 3, 3.5 marks.
Okay. 3.5.
Next up, we have Shapley values.
Okay.
We are at 10 marks out of 50. We have click-through rate again, advertising.
Mm-hmm. Same answer.
Yep. Same creditor. Mostly, I'm guessing this won't be much of a change given that this is Fn and An of the same one. They
Oh.
changed the value here. It was 0.75 in Fn, An is 0.6, but same concept. Expected revenue of the seller, same concept. Base
Okay.
theorem, spam
Yeah.
versus not spam, good versus bad, defective, and containing the phrase. Fair. One question of base theorem, worth 2 marks or 3 marks.
Mm.
2.5 in this case, 3 in Fn. Fair.
Okay.
Oh, this is the same question. It was the first question in that paper. It is in the middle in this one. All theoretical, no derivation, nothing.
2 plus 1, 3 marks. Then more. It has many parts, huh? This one.
Yep. Around
3,
5,
4, 5, 6. Yeah, 6 marks for just this one.
8,
7, 6, 8. Oh wow, 8 marks.
9,
9 marks. Oh my god.
9 marks. That's
Jeez.
20% of the paper.
Yeah. Okay.
So that is
What a
going to be
mark
fun.
rounds.
Same question. We know the answer by this point. A plus AJ divided by 2 is the best response. E1 equal to E2 equal to A. Same question, 6, 18, 30 or 6, 24, 30. I've forgotten.
No, the lower number has been changed. It was
It's
18, right?
24. Yep.
Yeah, 6. Yeah.
Yep.
Okay.
So 8 something and 32. Yep. 8, 30, 32. Fair. Same question, 150 by N.
Mm.
5 numbers sorted from, okay, 1 by 3. Player 4 is null. Crowd can be wrong. Stable matching.
Different.
Same,
Right.
same.
Same. Okay. So we're done. The
Yep.
last one, the last previous one, right? Okay. So we have one term left.
Yep. And here it is.
Okay, we're doing it now. All right.
Let's finish this up. So check this out, is back.
Okay.
0.0064. Here we go. Same question. this is different, but
Yeah.
the is
1,
just
2,
remains
3.
the same.
So we divide 13 to 3 and then add up the individual ones, right? Okay.
Correct. So player 1 pays 15, 10 plus 5. Player 2 pays 10 and 5, 15.
No,
Player
not we'll play 5 now because 2
so
and
10
3
and
will
5.
play
10 and 5, right?
10 and 5, yeah.
15, 15 and 20.
Right.
15, 15 and 20. Good to go. Sequential game. This is new. If x is greater than 1, how many Nash equilibria in pure strategies does this game have? This is interesting. Let's take a look.
More than once, right? So
Let's take x as 2.
mm, this is that again reverse induction method.
Yep. Here we'll bubble it up. We'll take a look.
So player 2 will definitely can take either of these two games, right?
Player 2 will never take R. Player 2 will always take L because the
Yeah,
payoff
because
to
it's a
player 2 is
zero,
better.
right? Player 2 will always take L,
Yep.
and this guy knows that he's going to take L. So
But player 1
and
is
then
also playing
D,
rationally. So player 1 will go down this
then
path.
D. Yeah,
Correct.
but they know that their thing will be at least two.
Correct.
Will be two,
Absolutely correct.
right? Which is anyway higher than the one they would have got with up.
That is correct.
So, right. So only one.
Yep.
If there was a division under player one's up, then there could have been multiple Nash strategies.
Yeah.
Okay.
So a single Nash equilibrium in pure strategy. If
Mm,
x is less than 1, how many enemies in pure strategy does this game have?
okay, less than one. They come up. So it'll be zero.
So here we have, in fact, let's take negative -1 and 0.
Yeah, but then why would I would still say you would have taken only one, right? There is no other Nash strategy.
I would still go with D, comma L. You are right. But then why is he mentioned it as -1, comma 0? Should we ask this?
I think we should.
See,
Is
careful.
it from a GA?
No, not that I remember. Does not seem to be. Let's see.
Okay.
The only way I get 2 Nash equilibria is if no,
Nobody wants to change.
I don't get a Nash equilibria. I was going to say that if player 2 decides to time player 1's payoff, but that is not the sign of a rational player. And player 2 will
Yeah, but
instantly
see, but tell
go.
me something. What if player one plays you, right? They get a one. So is it because of probability that there's a 50% chance and of getting one and 50% chance of getting -1? It's not that, right? We are going by rational
Actually,
players.
that might be that you might be right. I think this could be a case of imperfect information, right? Player 2 doesn't know player 1's payoff, player 1 doesn't know player 2's payoff.
No, they do, right? There's, it is sequential game, right?
Ideally, yes, they should know, but in the only
Player
reason,
one doesn't know what player two will play, but they know the payoffs, right?
हाँ तो वही है ना कि since player 1 doesn't know what player 2 will play, but player 1
But they
knows
know
what,
that they'll play rationally.
हाँ, but then player 1 knows that the payoff is 1 here and 0
Yes.
here for player 2. So player 2 will obviously go for 2, comma 1. We'll have to ask this, I think.
Can you make a matrix for this?
Let's make it.
Okay. We'll have to ask this, right?
Yep.
Uh,
Up
okay.
and left.
So up, left, right will be the same 1, comma 2. Player 2
Uh,
doesn't get to play, so it doesn't make a difference.
Correct. Down left is 2, comma 1. And down right is minus 1,
One,
comma 0.
0. Okay. So player 1,
Player 1 will always play you. No,
player,
sorry.
no, down.
Player 1 will play.
Yeah, for L, thinking that they'll play L, they'll play D, and if it's right, they'll play up.
Yep.
Okay. Now player 2. Player 2 is indifferent for up and definitely L. Yeah, so there are two national NEs. Yeah. See that there are two NEs now.
First inning is N, comma D.
First NE is so I go by a different method, right? So I go with what player 2 will play. Sorry, if player 2 plays something, what will player 1 play in both these things? So they'll play it down. So can you circle down left?
So L, comma D is 1.
Right? So player 1 would play this, and if it player 2 plays right, player 1 will play 1, comma 2.
Uh-huh.
So circle that. Okay. Now, if these circles get double circled, that means
Then
it's a
that means it's a Nash
equilibrium.
equilibrium.
Okay. So player 2, if player 1 plays up, is indifferent. So we'll play both. All right. Now, if they play down, they'll do. So now there are two Nash equilibriums.
Fair, makes sense.
Okay.
Okay, so we don't need to ask this one.
All right.
Oh,
Like
if
this,
I'm
now we
saying,
can just substitute the values and figure it out.
yep.
Mm.
If X is less than 1, what is subgame perfect Nash equilibrium that we calculated is L, comma D, D, comma L, sorry.
Mm.
Easy enough. Same question, he just added a 0, 2800, 2000, 3000.
Okay.
Now we'll get 20,000, 28,000, and 30,000 going by the pattern.
Mm. They really work hard for their money, right?
Yeah.
Mm.
V of 1 is 2000, V of 2 is 0, V of 3 is 0, 5 is 0, 2 comma 3 is 0, 1 comma 2 is 2800, 1
3,000.
comma 3 is 3000, 1, 2, 3 is 3000, done.
Mm. It just doesn't want
61, 19, 20, 20. If the Shapley value of this game is so and so, then the
dictator.
value
So we
is
have
1.
a dictator, right? S1. So S1 is 1,
Correct.
all others are 0, right?
Correct. And the reason why all others are 0 is because without 1, all of them, even if they come together, 99, 20 is 39, 39, 20 is 59. Without 1, they still cannot complete the quorum. They need 1. And so the value brought by every other player to the table is 0. All of them are null and 1 is dictator. S1 is 1, all others are 0.
So even if they were like 60, they would still be 0, right?
You will only get a Shapley value that is non-zero if these sum up 61.
Mm.
Otherwise, the whitest will not be there. Here, Shapley,
Okay, so this will come.
I hope so.
It was not there in the previous paper.
Yep, which
No.
is why I hope here Shapley comes. It's
Right.
easy. We solve this.
I don't think we need to, right? We've done it so many times.
Yep, let's go. He hasn't changed the answers though. None, C, B, A. Same thing.
Mm.
Shapley value again. Find the null players. Null players,
Zeros who
correct.
don't add any value in a coalition.
Correct.
Symmetric players that can be replaced with each other. So players with equal value in a coalition.
So 1, 2 are symmetric and 3, 4 are symmetric.
Right.
And uh,
One
null
question.
players are 1, 2. That's all he asked.
Mm.
This is partnership resolution, finding the Shapley value again.
Yeah. Just find the Shapley value. You don't have to do the table.
16.67, 36.67, and 6.6.
How do you remember that?
This is going to be my dumper in the paper. That we
Okay.
to go and blindly put these values and use
Yeah, just
change the
vomit it out.
values.
Yeah.
Yep.
Okay.
Fun. 5 fiddles with private valuations. Oh, not this again.
Okay.
Same question.
Mm.
0.75 becomes zero point 0.6. Then expected revenue is 2/3.
Mm.
Uh, Statement
Dominated.
1 is D is weakly dominated by U, which is correct. U is at least as good as, if not better than D in each and every aspect.
Right.
Statement Q, L is weakly dominated by R.
No.
No. Only statement 1 is correct.
Mm.
D, comma R is a Nash equilibrium. Correct. 0, 0 is a Nash. Elimination of weakly dominated strategies also eliminates D, comma R as a Nash equilibrium. That is correct.
How do you get that?
R,
Okay, because that's DR, right? If you
ah,
remove DR, you lose one NE, right?
correct. U, comma L is the strong one.
Mm.
3 firms, not again. 3 pure strategic equilibria, 4/5. Political parties, here we are.
This came in quiz 2, this one.
Yep. I think it came in the quiz in the first quiz as well.
Yeah, this was repeated 2 times.
Let's hope it repeats third time as well. After
Don't know.
all, third time is the luck charm.
Okay.
Do we need to solve this? It's the same thing. You just need to
Same thing.
differentiate.
Differentiate and then solve the whatever
Correct.
equation you get. Yeah.
Correct. This is the ones of where we get delta.
Yeah, to T minus P over T minus R, right? T minus R over T minus P.
Uh,
So delta greater than equal to T minus R over T minus P. Okay. So T is temptation. That's the value if they defect and the other one doesn't. So in your you can check whatever that value is. Payoff is minus R is the reward for mutual. So when both of them are C, both of them are complying, the payoff that you get, you
is
subtract.
0.
Okay. And then T minus P. So T is again the same value. P is the punishment. So that means they both have to deviate.
Yep.
They both are deviating. Minus one, I guess that was.
Yep.
I don't
So
know.
1/4 minus minus 1. So 1/4 plus 1.
Hmm. So here it is less than equal to. So we just have to switch the sign because this is for delta is greater than equal to. This formula works with that.
Say that again.
The formula is delta is greater than equal to this T minus R over T minus P.
Mm-hmm.
Okay, so you'll get a negative value or something, then you should get this. You'll have to switch it around the
Switch
sign.
it around. Yep.
Mm.
Fair. I think this is the last. Yep, this is the last. Let's look at the AN result for E224. Shapley value, nothing out of the ordinary here. For joint enterprise, nothing out of the ordinary
We
here.
have done this. Yeah.
Null player identification.
Different question here. Okay, so if value of V2 only changes to 2, then if you look at the correlation of V1 comma 2, it will no longer be 0, it will be 2. Therefore, V1 will also change to negative 2.
Minus 2. Yep.
Okay, so that will not remain null.
Yep.
Hmm.
Defective and good, same question again.
Hmm.
5 belows. Oh, okay.
Yeah, I'm sure 80% is easy to score this time. Maybe 90, 100, who knows.
100 is the target.
Yeah, make up for the lost score.
Yep.
Okay, next. What else? Done?
I think so. U
Okay,
comma D, L comma R,
same, right. Okay, matching.
Shapley, D forms. Cable TV, same thing.
So there are two questions with too many subparts. One is Gil Chaplin, one is the other one we saw. Okay,
The network was
not that the one that had too many subparts, right? A over V to the power of n.
the
A.
networking one. That is networking.
Yeah, so these two have too many subparts. So one of them will come.
Yep. And I guess it's going to be the networking one.
I'm thinking it'll be Gil Shapley because this is skip one term, right? The one that you're showing
Network.
them.
Yep. But networking is more difficult.
Okay.
Networking
Nobody's there in the morning session, right, for GT?
haven't received any positive responses.
Okay, then he'll only have one paper. So it's a good chance to get more predictable questions then.
Yeah.
Okay.
Nothing
Mm,
different. Same paper. Give or take 2 marks worth of difference. That's all.
okay.
And that wraps up game theory for us.
Thank you so much. Didn't take long.
Yep.
All right. Thanks, Bhavya. That was a good session.
Yep.
And now at least I know that there are only two, three topics that I need to study.
Yep. That's the best part.
Thanks, guys. All the best, everybody.
Yep. Let's see.
Mm,
All right. Thanks, everyone.
mm. All right.
Bye
We'll
bye.
meet CSD once more, right?
Yeah. We'll do CST probably day after. I have a long day at work tomorrow.
Tomorrow is what? Tomorrow is the live session.
Yeah. I'll try to attend that.
Okay, and then we'll study day after.
Yeah. We have a couple of questions to ask him. Like
Yeah,
that.
it's in that document. Yeah, it's
Yeah.
in that
Yeah.
document.
Cool.
Thanks, Bhavya. Good night.
Okay. Thanks, sir. Bye, everyone. Good night.